We'll start with the limitations of the PMTS method about which we talked. It's a data-based method which involves the consideration of the various micro elements of the job to compile the time for a given job. But this involves use of the database time values and requires a lot of expertise. These are developed primarily for the specific organizations, so these are company specific. So the few limitations of the PMTS method involves like this system is primarily used for compiling the time for the manual elements, the activities which are being performed manually, so manual elements only or manual jobs only. The second issue related with the PMTS is since it considers a lot of micro elements and the various factors associated with the job, so it needs expertise as well as the experienced the time study man, because it is a little complicated, and still some degree of the judgment and the subjectivity is involved. So little, not much, but little judgment and the subjectivity is there in considering certain assumptions or the situations. Another issue related with this PMTS approach is it is the company specific, so these are very customized, and there are many PMTS systems. Okay, many PMTS systems, so very few are there which are like the generic and in public domain. Otherwise many PMTS systems are developed by companies for their own as per their convenience and the requirement. Then there is a possibility, like since the existing way of doing the job is analyzed and then time values for those different components of the job is identified through the database. So when the method is being analyzed, there is a possibility of incorrect assumptions related with the way by which work is being done. Okay, the next point related with this is that it doesn't consider the effect of the preceding activity or the following activity effect on the time that a job will take or a particular portion of a job it will take. So no consideration of the preceding or the following activities, no consideration for the effect of the preceding or the following activities on the time that a job will take. Okay, so the next is related with this, like it's not cost effective when especially when the non-repetitive elements are happening. So not cost effective for non-repetitive elements or the jobs, and as I have talked earlier, like it's not possible to have the all kind of the elements or the elemental times for all situations. So 100% coverage of all activities through this is not possible. So these are the few limitations. There are many advantages associated with, especially one where it doesn't involve the performance rating. One, it doesn't involve or we get the time value for doing a particular job before it is actually performed. and that is used in number of ways like scheduling, planning, line balancing, or setting the line, changing the layouts, etc. On the similar lines, standard data method is the another method, but it is relatively simpler. It doesn't consider those micro elements in analysis of the job, but it is more macro in nature. Now we'll see the details related with the standard data method. Okay. Standard data method, or this is also called standard data system. Okay, so just like PMTS, the standard data method is also data based method, means it uses the data available from the past history and the record of the time studies. So based on the data based approach, okay, it uses this data of the various time value data of the time values for various activities from the earlier time studies. Okay, so it uses the data of the earlier time studies which have been established and documented earlier. Okay, so the data from the direct time study observations is used. Okay, this is one important thing. At the same time, if it can also be, mostly it is coming from the time study, but for few situations it can also be compiled from the PMTS approach. So PMTS approach is micro in nature, while the standard database approach is the macro in nature. For major activity or major portion of the job, the time is obtained, say, from the PMTS approach. So I will talk about, like, this is what is the micro and what is the macro aspect. Like earlier what we have used for analyzing the PMTS method, like the reach, grasp, then move, okay, position. So the various time values for all these micro elements was used for a simple job, like the pickup, the shaft, and position in the bearing, like last time I told you about this. So these are like micro elements, and the time for each element is identified depending upon the weight, or depending on the distances to be traveled. But here it is not so. The nature of the job is more macro in macro, or it is larger, it is of the larger duration. Okay, so the database primarily coming from the time study, and also can be compiled, if not available in the time study, from the PMTS. Okay, like how useful the standard data method is. Okay, so say for example, it's very quick, like sometimes even in less than 2 minutes you may get the time required to complete a job using the database kind of thing. So it's very quick. Otherwise time study, it may take 30 minutes, it may 1 hour, setup has to be there, job is to be actually done. But here it is not so. The second is, it's very cost effective, because it doesn't require the job is performed, and it is more macro in nature. So you just consult or consider the data available from the past time studies, do little calculations, and get the time required to do the job after compilation. And it is reasonably accuracy, like say plus minus 5%. So reasonably accurate, and like the PMTS method, we get the time, or we can set the time standard even before the job is done, before job is done. So we can get the time even much earlier or before than when job is done. So this is extremely useful in, like, say, costing, developing layout, developing jigs and fixtures, etc., planning, scheduling, like that. It is also easy to explain the worker. So easy to explain, so there is no union kind of issues, or it because we are getting the time without performing the job actually, and it is very easy to explain to the workers as well as the union people. So this is very good side as far as this the method is concerned. And another good side is the time obtained for a unique situation for which the time in database is not available. Now this can be used for cross checking the time study data again when it is done actually. So it also helps in cross checking the time study data or the time study which is being conducted. Okay, so cross checking of the time study, easy to explain. Time is obtained much earlier than when it is done, actually done. It's quite accurate and consistent, and cost effective and very quick and fast. So these are the very positive sides as far as the standard is concerned, standard data method is concerned. So when it is applied under what situations? So situations where this kind of the method fits in well, situations suitable for the standard data method. Standard data method. So there are few situations only where this method fits very well. Say for batch production. Okay, if it is continuous production, then what will be done? That is a different thing. In batch production, say initially a batch of 50, then batch of 120, then batch of the product A, product B, product C. So the different batches of the different products need to be produced. You can find out how much time it will take and how to compile the time for a unit product, how to get the time for entire batch. So in batch production, this is found to be extremely useful. I'll give example related with this also. Then in the shops or the companies where many similar kind of the jobs, not same but similar kind of the jobs are performed. For example, cutting, making the jobs of the different diameters, of the different lengths, washers of the different thicknesses and the different diameters. So but all these are the different in terms of the dimensions, but the kind of operations which is to be performed in all these may be similar. So similar type of the jobs, wherever the similar type of the jobs are being performed, this can be very effectively used to set the time standard using the database from the time database which is developed over a period of time from the time study. Okay, then this is for this is also used when we have the situation of like say setting the, as I have already talked about this, setting the standard time for the batch production. So these are the three common situations, like similar type of the jobs or the batch production. These are the two the common ones where it can be applied very easily. But like the advantages, there are many limitations. In the last slide I talked about the many advantages of the standard data. Similarly here we will see the many limitations associated with the job. Okay, sorry, in the standard, many limitations associated with the standard data method. Say the standard data method like PMTS is very customized. limitations, or you can say the uniqueness associated with the standard data method, that is, or you can say uniqueness associated with the standard data method, like it is extremely customized, suitable for a particular type of the industry where similar kind of the jobs are being done in the different in the industry or in a particular shop floor. So it is very customized or unique to the product, method or methodology of manufacturing. Then because of this uniqueness to the product and the methodology, it is extremely customized, and therefore it is not easy to apply the standard data method in some other companies. So migration of the standard data system from one company to another one is not easy, because it is extremely unique to the product methodology which is used for production or for manufacturing particular type of. So no easy migration, lot of allowances or adjustments are needed otherwise. So uniqueness of the standard data method is, it is customized and unique to the product methodology, no easy migration from one company to the another one. Okay, so how it is done, how the this standard data method is applied. So the steps of standard data system or data method. Okay, so how it starts, like the first thing is write about the objective of developing the standard data method. Objective will include what is the scope, what is the accuracy, what are the different elements, like that. Then we have, I will talk about each of these steps in detail a little later. Next step is here it is coverage or scope. What are the different things which are which will be included in development of the standard data? So what for it is being developed, and what are the what is there in scope or the limitations of standard data development. So the data has to be developed, and then the time values using that will be extracted using the different approaches. So objective of the developing the standard data system, then coverage or scope of developing scope or limitations with regard to the development of the data, what for it will be done. Then we have the establishing the time for different elements related with the job from time study. Okay, so now whatever the different elements are related with a particular job, the time for those is obtained from the data sets or from the time study database. Okay, like I'll give one simple example. For turning a simple job like this, what are the different steps needed and how to come out with the time required for doing that? Say so the first is hold the job. Okay, then then the set up the tool, then start the machine, then perform turning, then unhold, and then place the job aside, or like dispose of the machined job. So like this. Now here you see, holding the job, whether it is 10 mm diameter or 12 mm diameter or 8 mm diameter, this will take the same time. Setting up of the tool will also take, by and large, if many jobs are to be produced, then setting takes just once, and that time will also vary by and large with a little magnitude. Say it may be just 2 minutes or 2.2 minutes or 2.1 minute or 1.9 minutes, like this tool setting time. Start the machine will always take some constant time, say just say 2 seconds. So turning, now time for turning will depend upon the length and the number of passes, the extent of reduction which is needed. So there can be number of variables that will be affecting the time required. Holding, unholding will also take same time or almost constant time, and this one will also take almost constant time, setting aside or disposing of. The point is, from that time study database, we can get the time for holding, we can get the time for setting up, we can get the time to start, we can get the time for turning a given length, say one diameter, one length. We will not be having, like we may have the diameter and length relationship like this. So say 10 mm diameter, 12 mm diameter, 15 mm diameter, 20 mm diameter, and for different lengths, how much time it takes. Okay, like this. Say 20, 50, 100. These are the certain, say, length values for which time is available. These are the certain diameter values for which time is available, and this kind of the data set is available, say, in the database. Now what we can do, we have to just identify the time values. So these are the standard data things which are available. Say we have to turn the 14 mm diameter of 30 mm length. So this is something for which data is not available. So time value for turning the 14 mm diameter and 30 mm length will be obtained from this database. How it will be done? We can use simple calculations, we can use regression method, we can use a graphical method. So there are a number of approaches for arriving at the time value for a particular element for which the time is not available in the database. So those elements for which the time is already available can easily be identified, but for those for which time is not available directly, it has to be calculated, computed, analyzed. Okay, so based on this, if you see, this is a very important step as far as the standard database method. I have talked about the objective, I have talked about coverage, and this is the establishing the time for the different elements using the time for the different elements from the time study or from the database which is obtained. Okay, now next is like this, there are many other examples. Next step in time study is to see like classify, describe the method, classify the elements. As I have said already, there are various elements associated with the job. There are few elements which are for which the time will always be constant. There are few elements for which time will variable with a certain parameter related with the job which is to be done. Okay, so the one simple classification of the element is like setup time and the production time. Setup time, say 20 minutes, and production time will change as per the volume which is to be produced. Okay, if the batch of 30 is to be produced and if 1 minute is the time for producing each job, then 30 minutes. If the batch size is 50, it will be 50 minutes. If it is 100, then 100 minutes. So there is a setup time which is most of the time constant, and the production time that will depend upon the volume to be produced. Okay, so say just for example, time to produce a batch, say T batch of 100, okay, 100 units to be produced, that will be equal to the time for setup plus the Q is here, it is 100, say that is the volume to be produced, and the cycle time for producing the per unit job. Okay, so this time, cycle time for per unit job, that can be easily obtained from this standard database method. How it will be done, that will be about that will be talking little later. So let's see. So what is this? The production time is a variable and the setup time is a constant, which will by and large will remain maybe 19 minutes, maybe 21 minutes. So you can get the average value as well for this. So there are certain constant variables, constant elements, certain variable elements. So here, depending on the nature, we are classifying the elements in different ways. So one is setup and another is production element. Okay, and depending upon the nature, we can also put them as a constant element and the variable element. Variable element is one, like the element for which the time required will change as per certain characteristics, like the length of the job to be machined. Short job, less time; longer job, longer time. Similarly, the thickness of the depth up to which hole is to be drilled, it is less or it is more. The floor area to be cleaned, say floor area is just this much or floor area is large. So with this certain variable, the time to complete the job will be changing continuously, and that relationship has to be identified. So for certain elements the time is constant, for other elements the time changes with certain characteristics, not just one, it may change with the number of other characteristics. So it may be univariate, it may be multiple variate, means the time may be affected to complete a particular element may change with just one characteristic or number of characteristics. So about that we will talk, how to arrive at the time values in those cases. Then element also is to be shown like manual elements or machine elements. These elements are different from what we have talked in the time study. Okay, manual element, of course, it is the job which is done and under the control of the operator, and the machine element is about the time for which for a given set of parameters, the time for which can be calculated directly. Okay, so here this is the regular elements and irregular element. So regular element will always be happening in each cycle, like holding and unholding the job. Okay, but the setting up time may be irregular, like that will depend upon the setup, the batch size. So the setup will remain same for producing a batch of 30 or batch of 200. Okay, so there are certain elements which will be repeated in every cycle, so they are regular, and certain elements which are repeated either at regular or irregular intervals. Okay, then there is a kind of what is that element? Internal and external element. Internal elements are those which are done in parallel with some major activity, like when machining is being done, the job diameter is checked or cleaning is done. Okay, and external elements are those which are done in series. So here the time consumed in internal elements may not be counted with the, or may not be added with the time required to complete the job, but when certain elements are performed in series, like hold the job, okay, then perform turning, then unhold the job. So these three are in series. So this is external element. So internal elements are those which are performed in parallel to the some other element, which other element or other job when it is being done, and external elements are those which are performed in parallel with the other elements. Okay, so this so each job is to be a job for which the time has to be identified, time has to be established, the standard time has to be established, is analyzed considering these different elements. Okay, considering these different elements, so that you can get the time either from the database. So primarily these are the variable elements for which lot of computational or calculations are needed, while for others probably the time from the database can be obtained. Okay. Sorry. So now I'll show you one simple example. Okay. So let's see. Yeah, this example. So in this case, you see, say this is an example of cutting the wood sheet of the different widths. Okay, like this. Okay, so this dimension is W, for on which cut is being made like this. Okay, and then here we have the thickness, right? So this thickness can be of say 2 mm, it can be 4 mm, it can be 6 mm, 8 mm, like this. There can be different thicknesses. So the relationship through the actual time study or from the time study direct observation data, the time for cutting the different widths means cut length. The width corresponds to this cut length. Okay, and this is say thickness of the sheet. So time for cutting the wood sheet of the different widths is plotted in x-axis. It can be in tabular form also, that is fine. This is just for this is a graphical method rather. Okay. Now the time for cutting the 2 mm is plotted like this. Time for cutting 4 mm is plotted like this. 6 mm and 8 mm likewise. Okay. Now if we have to cut, so that first here the time required to cut the sheet is significantly affected by the length of the cut or width of the sheet which is to be cut. Okay, but that at the same time to cut is also affected by the thickness of sheet. Okay, obviously thicker is the sheet, greater will be the time that it will take. So the certain time values are already available in databases. Okay, say for 2, 4, 6 to up to 2 to 16 the time is available for entire width. For a plate or for the sheet of say thickness 2, 4, 6 and 8. Say if it is required to cut the 3 mm thick sheet of 12 mm width of say thickness is 3 mm and width of sheet is 12 mm which is to be cut. So what we'll do, we can simply draw one line like this, okay, and get the time value. So in tabular form the time value will always be there. Obviously for cutting the 12 mm we have the time for cutting the 2 mm thick sheet, right? We also have the time for cutting the 12 mm width, that is already there with us. So this is the time that we have. So for cutting, and what we also have is time for cutting the 12 mm width sheet and 4 mm thickness. The time for cutting the 3 mm sheet is to be determined. So obviously the time that it will take will be greater than this A1, that is the time required for cutting the 2 mm sheet, and it will take lesser than the time that it will take to cut the 4 mm sheet. Okay, so how to arrive at, say this time value is corresponding to the 12 minutes. Okay, and this corresponds to the, this is the same example, I'll come to this. Say this takes say 18 minutes, right? So time for cutting the 12 mm width is same for all the cases. For 2 thick sheet it is 12 minutes. For 4 thick sheet it is 18 minutes. Okay, and time for cutting the 3 sheet is needed. So obviously the time for cutting the 3 sheet will be greater than that is needed for 12 minutes, and that will be somewhere here. That will be somewhere here. Okay, but we don't have exact data where it is. So what we do, this is a simple equation which is used. T is equal to A1, that is the time required for cutting the 2 thick sheet, plus obviously it will take extra time, but how much extra, that we have to determine, like time for cutting of the time available for 4 sheet and time available for 2 thick sheet. Okay, so here that is 18 minus 12. This is the extra time is being taken to cut the 2 to 4 sheet. So but we have to determine the time required for 3 sheet. So we determine the relative thickness. Relative thickness is how much? So here out of this total, this 1 extra, and the total range is 2 2 to 4. So the relative thickness is half. So we will be multiplying this half. This basically F is the relative thickness with respect to the thickness data for which the time data is available, and the thickness which is to be cut in. Okay, so the T for which the cut is to be made, extra cut is to be made, and the time range, the thickness range for which the data is available. Okay, so this is how we'll be getting, say, 12 plus 18 minus 12 into 0.5. This is how we can get the time. So say value, this is what the solution is. A1 and A2 are the values of 12 and 18 minutes for cutting the thicknesses of 2 and 4 Okay, a relative thickness value of the factor F for the plate to be cut 3 with respect to the plate thicknesses of 2 and 4 is like say 0.2. Okay, so here we'll have the 12 plus 0.5 into 12 minus 18. So this will give us say 15 minutes. So for certain thickness, if the data is not available, it can be calculated. This is the this can be graphical, this can be analytical, or there can be simple regression analysis also, when either univariate or just a single variable is available or multiple variables are available. So depending upon the situation, the suitable regression equations can be developed to find out the time required to cut or time required to complete a particular activity. Okay, so here, okay, so this is one example. Let me talk about this example first. Okay, so in this this is an example. Consider a worker in a packing plant whose job is to remove the curtain of fruit from conveyor belt, stencil the name of customer on the curtain, and carry to the nearby skid. So this is the job which is being done. So it is being broken into the few workable elements. Okay, like lift and position the curtain, position the stencil on the curtain, apply the brush and the tar to the stencil and the same is pasted, lifting the curtain, walking with the curtain and placing on the skin. So you see, in this case lifting and positioning is something that is the time for which will always be constant. Positioning the stencil will always be constant. Okay, then applying this may also be constant. Lifting may also be constant, but the time required to walk will depend upon the distance to be traveled. Okay, it may be 50, it may be 100, it may be 150. So there are certain elements, certain activities for which time by and large will remain constant, and for those the time can be obtained either from the database for a given type of the activity which was established through the direct observation, and then that can be used for compiling every time the new situation comes in involving similar kind of the tasks or activities. Okay, now one important thing which is done in standard database method is this, like since there can be number of different situations, number of different activities with a lot of variables. Okay, so how the coding is done? It is required that some kind of the coding is done so that database can be effectively used. Okay, so develop coding system so that it can be easily identified and recognized. Say just for painting of the different areas, time can be identified, a time can be established. So paint 10, indicating that painting area up to 10 mm square. So P and T is a kind of letter, or 10 is a kind of code indicating the kind of the variable for which the time is being indicated. Okay, and based on the kind of the basic motions involved and the frequencies, these are ranked. Okay, so important thing is just coding and then ranking. So here this A is in a particular order, indicating that maybe the time values are increasing, or certain time value for certain activities will be increasing, for certain it will be constant. You don't know at this stage what for 10 exists. Say what for 10 exists, you don't know. And say these are the different models of a particular product, 119, 130, 220, like this. So there are different products for, and these are the different activities which are to be performed, and these activities are same for all models. These are the different types of the products which are being manufactured, needing the similar kind of the operations. Okay, 10, 20, 30, 40. These are the codes of the different activities which are needed. Okay, and these are the different the models of particular product which are being made. If you see, and within the table you can see the time values which are needed. These may be in minutes, these may be hours, depending upon the case. Now if you see the element 10, this element, how much time it takes when it is used, when it is performed for the different kind of the products, different models, say 0.24, 0.22, 0.23, 0.23, 0.24, 0.22, 0.23. So there is no consistency, there is no trend. Sorry, there is no trend. The time is by and large hovering from 0.22 to 0.24, and there is no major change with the model which is to be manufactured. Same is true here, 0.38, 0.35, 0.35, 0.37, 0.36, like this. So there is no change. So element 10, element 20, the time is not changing for the different models. Okay, whether it is model 119 or model 329. Similarly for this, here you can see some kind of change. Earlier for 119 it takes 12, then 10, then 8, then 6, then 10, then 6, then 7. There is at least some kind of the trend. Then here 40, some kind of the trend. So from the data value, from these values, you may not be able to understand what is happening, what is going on. Okay, so whenever we see that there is some kind of the trend, some kind of the pattern exist in, now that pattern has to be seen depending upon the, but here just this coding is not able to give you complete idea of, okay, how it is changing. So we'll talk in detail about those in the next lecture. How do we arrive at that time value? So this is just the classification about the steps about which I have already explained earlier, like the classify the elements like major or minor, whether it takes longer time or the less time. So major factors or the minor factors which are being affected by the different variables. So you know, walking a particular distance, major factor, say, so major factor, consider the activity called restricted walking, which is defined as starting at the dead stop and ending at the dead stop. So from particular position to the another position, the time required will be dependent on primarily the distance. The minor factors can be temperature, humidity or the lighting, but these will not be affecting significantly. So we will be picking up the distance variable to develop the kind of relationship like this. So here we have the distance and here we have the time, and we can develop a plot like this. Okay, it is possible like for 10 kg load, this is the plot. For 5 kg load, 20 kg, this is the plot, and for it may be taking longer time. So for 2 kg this is, and with the 30 kg this is the kind of trend. So it takes long time to cover the shorter distances. So in the different working conditions, the time required may be different. The point here is the major factor that will be affecting the time is the distance, and this relationship is established. So you can have simple y is equal to mx plus c. This kind of this is also kind of the regression equation which is developed. Through the regression you can develop suitable equation to find out what is the kind of relationship between the y and the variable, on what are the different factors which are affecting this. So regression helps a lot, the graphical method and analytical method, these are the two, or regression method, these are the two very extensively used in establishing the relationship between the time and the given major variable. Okay, so this is how it is done, like develop the charts, develop formulas, and using the Excel also you can do the regression analysis to find out the equations, like the time will be the function of some constant, then mx plus some variable y, or if there are other factors like c plus m, y, and x. So in multiple variables you may have this kind of if there are two significant variables, like we talked, like width and the thickness, these are the two main two significant or major variables, then you need the regression analysis involving the multiple variables. Okay, and eventually what we have, we just compile the time, prepare the documentation, just compile the time for constant activities like start the machine, time it takes, say hold the job, start the machine, perform turning, unhold the job, and then put aside the job. So these are the kind of the different activities that are needed to produce a job. Then time for each of these elements, for certain elements it may be constant, like for many elements it is constant, so that time for those can be obtained directly. The time which can change is the like turning time, depending upon the variables So the relationship of the time and the variable is established, and then it is calculated using suitable